So hello everyone, this is the Promoter channel. Today we're going to take apart this engine. This is a Mercedes-Benz M441. It was bought in Poland, so it hasn't been used in Russia. The engine was bought for repair and subsequent installation in a vehicle. The customer already has a car. It has this type of engine installed. The car still runs and operates, so I'm currently repairing the engine. I also have a 16-speed gearbox in for repair, which will work together with this engine. I'm repairing the engine, repairing the gearbox, and then the customer will come with his car when everything is ready. And we remove the engine and gearbox from his car, then install this engine with this gearbox. So that's our plan of action. So you could say that the customer bought himself a replacement engine, and my job is to repair it. So this engine has the following technical specifications. Well, basically we see a standard 441 engine. So how is this engine different from the engines I've had on my channel before? We can see that this engine has a decompression valve, just like for example on the 1501, the fifth valve. But here it's not the fifth valve, it's the third one. There are two valves per cylinder here, plus an additional decompression valve. So that's a feature of these cylinder heads. We can see that some bolts on the heads are unscrewed. The customer already removed some engine parts, including the cylinder heads, and installed them on his own vehicle. He also installed the entire manifold and turbocharger on his own vehicle, which he is currently using. So this is a typical engine for my channel. It's a standard job, meaning we completely disassemble it, inspect for defects, do some of the work ourselves, and send some parts out for machining. Alright, so this is the engine we have, another M441. Let's start disassembling it. As you can see, all the manifolds and pipes are still in place. So that's what we're dealing with. This is the intake from the air filter. Here it goes to the turbocharger, the outlet from the turbo goes to the intercooler, and from the intercooler the cooled air goes into the intake manifold. You can see how everything is set up here, how tightly everything is assembled. That's the amount of work we have today. Let's get started. So as you can see, the clutch disc is new, meaning the customer said he had already tried to put something together there, and the clutch pressure plate has been repaired. It looks like the surface was ground down, but it feels like the grinding was done in such a way that an angle grinder and a disc, well, I don't know. The customer said to install this clutch, so we'll use this clutch. The pressure plate has already been repaired and the disc is new. Now let's take a look at the flywheel as well. Well, basically the flywheel is also in pretty good condition. We'll probably keep this flywheel. Be continued. Let me start with the manifolds. The client said they will need to be replaced because, as we can see, they're badly corroded. And you can see from the outside that several millimeters have already been eaten away. Also, the gasket seat has a very deep pit, more than a millimeter. Here you can see the wall is already this thin. So most likely we'll need to look for other manifolds. These ones will go to scrap metal. I think maybe possibly we could grind it on a surface grinder, but that's not really an option here because first of all, you'd have to remove too much material, and secondly, the walls themselves where the bolt rests are already thin. Right here in this spot it's just a couple of millimeters. See, for example, you can see how thin the wall is. It should be 3 times thicker. The manifold shows the year of manufacture, 97. I don't know what kind of condition this engine was used in, that since 97 the manifold got worn out like this. I don't think I've ever seen manifolds this worn out in all my time working, to be honest. Interesting.
Subtitles by Dimatorzok and to be continued.
Next, I disassemble the compressor, remove the head, and take off the piston with the cylinder. To remove the piston, we take off the rear plate, and the piston should come out. So, we see here that there are some homemade bolts, possibly made from some studs. We can see a welded nut here. Well, we'll see, maybe we'll leave these, or maybe I'll look for original factory bolts. If we find them, we'll put them in. We're taking apart the compressor. Then we remove this cover here. It covers the fuel pump gear. And then we'll start removing the cylinder head. The cylinder will have to be replaced. There's wear on it, and on this side something has been hitting it. There are some marks here. I don't even know how to explain it or what could have caused them. Alright, so I removed the cover. Now we're setting the fuel pump timing mark, checking how many degrees the fuel pump is set to, and then we'll remove it and start taking off the cylinder heads. Alright, I've lined up the mark, but the inspection window is still covered by the sensor. I'll either make a mark here or remove the sensor, check how many degrees it is, and then we'll remove the pump. Alright, now I'm removing the injectors. Since the cylinder heads were taken off and put onto another engine, the injectors aren't tightened, they're just inserted, and the head bolts also aren't tightened. By the way, the heads were on a surface grinder, as far as I can tell. We'll take them apart and check. Here we can see the third valve, the decompression valve. Here's what I did. I turned the engine over, removed the oil pan, and want to show you something else. There's this kind of plug made out of plywood. I don't know if it was put in just for transportation, or if the engine was actually running with this plug in place. I'll also show you this side of the block, where the rust is peeling off in layers like this. Well, basically everything rotates smoothly. You can only hear some play at the top dead centers, some play in the bearings, and maybe somewhere else. You can hear this free play when it goes past the top dead center and the bottom dead center. Alright, first I'll remove the counterweights. Then I'll take off the front and rear covers, the heat exchanger, and then we'll take out the pistons. So we can see that the marks line up, and we can also immediately see that since this has an electronic throttle setup, it has a simple gear without mechanical ignition advance, without weights, without springs. Alright, I removed one main cap, and first let's take a look at the bearings. So the condition is not bad, you could say it's good. The size is standard, year 1997, 36th week. Year 1997, standard. The Mercedes emblem and the Miba emblem, so as I've said many times, Miba bearings are supplied to the Mercedes assembly line. Here we see the Mercedes emblem and next to it the Miba emblem. Alright, now we're taking out the piston from the first cylinder. The piston is in pretty good condition. The connecting rod bushings, of course, very badly worn, and that's probably the play we heard when we were turning the engine. I mean, it's really bad here. Sometimes it's worn much less than this. So we'll definitely have to work on these bushings, but as for the pistons, it's quite possible that we'll actually keep these same ones. We'll wash them, clean them, and see how they look. Well, so far, as far as I can see, it really seems like this is a good engine. Actually, one of the best used replacement engines I've seen. Whoa. Whoa. Well, like I said before, it's a lottery. Some people aren't lucky, but this person got lucky. Well, I don't know, the camshaft is also in great condition, actually just excellent. At least at first glance, everything looks perfect. Let's remove the main bearing caps. First, we unscrew the side clamping bolts and then the main ones. Alright, let's check the main bearings. Well, the main bearings are a bit worse, of course. But, I mean, they're still in working condition. Yay! So they could keep running for quite a while. Well, obviously the size is standard. There's also the Mercedes logo. And it's also the 28th week of 1997. But here we can see the second main bearing is in bad condition. It even looks like it suffered from oil starvation. You can see some scoring and scratches here. I wonder what caused that. Maybe we have a problem with the oil passage here. We'll take a look and definitely pay attention to that. Well, as we can see, I just showed the condition of the first main bearing. The third one and the second one, it is just drastically different from them. Strange. Also, the fourth main bearing is in good working condition. Well, and as for the crankshaft, I don't think there will be any issues. In my opinion, the crankshaft will be perfect. It's standard size. Well, we can also see the other bearings all in excellent condition. The fourth, third, first, except for the second one. The second one, as we can see, is loose in its seat, meaning it doesn't even stay in place, it's bent. If the seat for the bearing is worn down in diameter, then we'll have to take the block to the machine shop. So I was already happy, thinking there would be minimal work, especially machining, and we'd finish this engine faster, but it turns out I was wrong. Here's a comparison of what the second bearing looks like and what the third one looks like. The second one is shiny because it was beaten up, and the third one was tightly stuck in there. It's the same on the other side too. Alright, now let's take a look at the lifters. The push rods also seem to be in working condition, but I can see some minor defects and pitting on a few of them. So, most likely the push rods will need to be replaced so that we don't damage the camshaft lobes in the future. I mean, they could still work for a while, but now they're going to start shipping the camshaft lobes. That is, these pits that have appeared here will only get bigger and bigger over time. Therefore, in my opinion, it's better to replace the lifters. So the engine is nearly disassembled. I just need to remove the sleeves, which I'll do with a puller tomorrow. I won't damage them. I'll carefully use the puller. Here's my conclusion on this engine. So the engine is in very good condition for a used replacement engine, at least in my experience. The only problem it has is the main bearing seat at the second main bearing. I'm showing you the condition of the bearing shell. In my opinion, the block definitely needs to be taken for machining, and this needs to be restored. Install new sleeves, install new seals. Leave the old pistons, replace the piston rings, and take the connecting rods in to have the piston pin bushings replaced and machined. Install new bearings all around, lifters, camshaft bushings, sleeves, seals under the sleeve, bearings all around, piston rings, seals, oil seals, all the gaskets. Send the turbocharger and fuel equipment for inspection. Repair the compressor and pump. We'll decide after inspection. Tomorrow I'll film how I remove the sleeves, so expect more footage then. So as we can see, there's cavitation. That's just at first glance. We still need to check the sleeve. It's possible that the rubber seals themselves also have cavitation. Well, most likely we'll need new sleeves because we don't know how deep these pits are. They might almost go through into the cylinder, inside the cylinder. So next I decided to take apart the cylinder heads to check their condition. As we can see, these heads have a third valve, the decompression valve. Basically it's almost the same as on the 501 engine here. I brought the old valves to compare and take a look. We can see that its stem is just a bit longer, literally by about 5 millimeters. Otherwise the diameter is the same. So I took it apart, first removed the valves. The working surface has this kind of cross-section both on the intake and the exhaust. The valves need to be replaced. The valve guides also need to be replaced. We can see this kind of play. Well, that's okay. All of this can be replaced. All of this can be repaired. So for the cylinder head repair, we need to replace the valve guides and the valves. Most likely we need to replace this piston here, which opens the decompression valve. But our biggest problem here is with this fifth valve. So I took it apart, removed the keepers, and somehow managed to get it out. It turns out it's all clogged with carbon deposits. That's why I brought the old valves from the 501. Basically, let's take a look. There's this kind of play. That is, the guide is worn out. Actually, the hole in the head is worn out. And the problem is that there's no guide bushing there. So you either have to make a custom one, drill it out with a reamer, insert that bushing, replace these valves. But that's still manageable. You can do something about that. You can see the seat. I'm not sure how well it shows on camera. But it actually starts about 1.5 millimeters in. As you can see, the guide is worn out, so the valve keeps sinking and beating up the whole area. Basically, there's nothing we can do. This means the cylinder head has to be scrapped because of this valve. The fifth valve, the decompression valve. Actually, the third one, fifth, that's on the 35-ton, 501 engines. So, well, I've only taken apart one cylinder head. At the very least, I can see that on this head the valve is also sunken. On this head, the valve is sunken, and maybe on this one. It's a bit better, but you can clearly see that on this head, the valve is just completely recessed. Here, even the valve head is almost level with the seat, but on that one it sticks out by about 3 millimeters, and here only one head sticks out. Here we have the original one. This is the one that came with this engine from Europe. Here we see a different decompression valve installed, but I think this is the only one that's in good condition. At least 4 heads are in bad shape. Now, I'll get in touch with the customer to find out, but first I'll sort out the head. I'll be contacting the customer to find out. So, does he even use this engine brake or not? The simplest option is just to replace the heads and install them without this third valve. We can block off the air system there, put a plug in. Even if we remove this decompression valve, the engine brake will still work anyway. It just won't be as effective without this valve, about 30 to 40% less effective. So this valve just makes the engine brake work more efficiently. Anyway, now I'm taking apart the other 5 heads and checking their overall condition. Well, I think it'll look about the same everywhere, and then we'll make a decision about the heads. So let's start assembling. I already have all the parts for this engine. Also, the block has already been machined for the main bearing seats. So we had a problem with the second journal. When disassembling, I showed that the bearing shell was sitting loosely here, meaning it was rattling around like this, damaged the seat. So the block has already come back from machining. Well, it's been about 2 months since we took it apart. Well, about 1.5 to 2 months, give or take. Well, now I'm starting the assembly. The first thing I'm doing is removing these caps. The bolts are torqued to spec, because that's how it was machined at the shop. I'm removing the caps, opening them, taking off all the plugs, cleaning, blowing out all the channels and washing them. I wash it again and blow it out. I'm still working on the block, rethreading in some spots, removing, cleaning and blowing out the oil nozzles. I'm mainly prepping the block before starting assembly. So, as usual, we start by replacing the camshaft bushings, then install the sleeves, the crankshaft and so on. That's it, so that's the scope of work we have. Let's get started. Установил. I installed the lifters, installed the camshaft. I turned the engine over. Next, I'll be installing the sleeves, so we'll have new sleeves. The pistons will remain the old ones, so we're only changing the sleeves and the piston rings. Alright, let's unpack the sleeves. Measure the protrusion of the sleeves above the cylinder block, and then install the sleeves into the block. Let's go. So I've installed the rubber seals on the sleeves, and using the fourth cylinder as an example, I'll show the protrusion of the sleeve above the cylinder block. I've already measured all of them. As you can see, the block is at 0. The sleeves are at... Alright, let's sum up. The block is at 0, the sleeve is at 800. The block is 0, the sleeve is 800. Well, basically I've already taken all the measurements, checked all the sleeves everywhere, so on all the sleeves the protrusion is 8 to 900, that's our upper limit. So that's actually very good. Alright, now I'm turning the block over and working on installing the crankshaft. So, I polished the crankshaft, blew out the oil channels, installed new bearings, put in the crankshaft, then tightened it with a gun. So, my gun tightens at about maybe 150, give or take. So now I'm tightening with a torque wrench. First to 250, then to 330. After 330 the marks are crosswise, then I turn it 9 degrees until the marks run lengthwise. So, I'll remove these marks now. The machinists torqued it down when they were machining the block. Now I'll wipe all this off with solvent and make my own marks. I'm tightening the crankshaft. Next we'll handle the pistons and clearances. The crankshaft is in, and now I'm preparing to install the pistons and connecting rods. So you were with us for 109 shifts. There was a replacement of the piston pin bushing, replacement of the piston rings, and restoration of the seats for the connecting rod bearings. Here we had an out of round about 0.06 millimeters, 6.700. So after the repair, we'll still be using the old pistons. I'll wash them and clean off the carbon deposits, put on new rings. Here are our new bearings, and the connecting rod bolts. The crankshaft is fully tightened with the main bolt side. Connecting rod bolt to 100 mm. Then turn the marks across by 90 degrees. Each connecting rod has longitude number on the connecting rod matches number on the connecting rod cap. So everything is done. The crankshaft is fully installed in time. So I installed the pistons and tightened the connecting rod bolts. The main bolts are fully tightened, including the main bolts and the side tie bolts. The connecting rod bolts are tightened. We also torqued them to 100 Newton meters, then turned it another 90 degrees from the crosswise mark to the lengthwise mark. So I checked that each connecting rod has side-to-side play. I also made sure that the number on the connecting rod matches the number on the connecting rod cap. So that's it, the crankshaft is fully installed and tightened. Next, I'll be installing the counterweights. I'm installing the counterweights now and tightening them as well. And then we'll be installing the front cover and the rear cover. And maybe, I don't know, I might close up the oil pan today. Alright, next I'm installing the front and rear cover. So about the front cover, I washed it, cleaned it, sandblasted it. I replaced the seal, chased the threads, prepared the gasket, and got the bolts ready. That's it. It's ready to be installed. So, what work was done on the rear cover? Well, same thing, washed it, cleaned it, blew it out, chased the threads, degreased the gasket surface, I got the bolts ready, and also installed a new seal. I chased the threads on the studs under the starter, put the nuts in place and hand tightened them, and also installed the new compressor crankshaft. So I installed the new crankshaft, put on the gear and tightened the bolt. I temporarily installed this whole cover without a gasket for now, because I'll have to remove it again later, to install the connecting rod and feed it into place. Well, I'll assemble the compressor in place as usual. Once the engine is flipped over, then we'll assemble the compressor and also L-in gaskets as usual, thickness 0.75 standard. Now I'm closing the rear cover. Applied a thin layer of sealant, installed the gaskets and checked the timing marks again. On the crankshaft gear we see a dot. On the camshaft gear there are 2 dots. The teeth are aligned. I coated the teeth with assembly paste, checked again that all the plugs are tightened. So we double check everything once more, look it over and install the rear cover. So next I install the flywheel. We're keeping the old flywheel. I've prepared it, cleaned it, sandblasted it, replaced this seal ring and got the bolts ready. So the flywheel is still in good condition. The only thing is that it was all rusty, meaning at some point apparently this engine was just sitting, or maybe it was washed that way. So it was all covered in rust, and here you can even see they cleaned off the rust with a grinder. You can see the marks from the grinder here, and on the other side I just sandblasted it. Well, the flywheel is still in good condition, so it will last a while longer. Next, I close up the cleaned oil pan. I unscrewed the plug. It has a rubber seal instead of a washer, so I swapped out the rubber seal. So I prepared the oil pickup tube. The oil pump will be new, and there will also be a new relief valve. I prepared a gasket for the oil pickup tube and a new gasket for the oil pan. And here we have all the bolts from the pump, from the pickup tube and from the oil pan itself. So I prepared everything for the heat exchanger, but I haven't installed it yet. Basically, I cleaned it in the sandblasting chamber and found a crack. You can see it starts around here. It's about 5 centimeters long. Here we have a solid plug in place. Right here, something used to rest against this spot. And this kind of crack has formed. So now the heat exchanger housing will go for welding. They'll weld it with argon. So next I'm working on repairing the compressor. I've already washed and sandblasted the head, the valve plate, the cover and the bolts. So the connecting rod, piston and cylinder will need to be replaced. Here we have a ring repair kit. This is a new connecting rod from Febuy. Here we have the cylinder, piston, liner and rings. Alright, so now I'm getting everything ready. Putting together the head, installing the new connecting rod on the new piston. Basically, I'm putting everything together and then I'll turn the engine over and start assembling the compressor. Well, then all work left. I'm assembling, repairing the heads. So what they were on the surface after they came back from the machine, I blew them out and Так, значит, продолжаю сборку двигателя и занимал. I lapped them well. So the valve is an old one, the old valve, the old air cylinder for this valve. Well, the customer said there's no need to do anything, he's satisfied with everything as it is. So we can see there's this kind of plate, the guide is already worn out and it can't really be replaced, so we need to change the head. There's play in some places the seat is worn out. In others the valve is worn out. So I had 11 heads and the customer sent some more heads as well. In the head there's play in some places. In some places the seat is worn out. In others the valve is worn out. Out of 11 heads I picked the best ones, 6 in total. My job is to give advice. It's up to the customer to make the decision. He made the decision, so I don't really argue with him about it. But I'll say right away the compression valve bothers me, and ours turned out to be about a 3 out of 5. Everything else with the heads is perfect. I suggested installing the heads without this valve, but the customer said he uses the engine brake. It's a necessary thing, he needs it, so he wants to have this compression valve installed. I also suggested the option of buying 6 new heads right away, already with the valves, already with a new decompression valve. But in general, the customer also said that it's too expensive for him. I'm starting to assemble the heads. As I already showed, the heads are ready. I prepared them. I also prepared the springs and the valve stem seals. Here we have washers and keepers. This is for the decompression valve. Washers, springs, pistons, the air cylinder on the decompression valve, and the old guide pieces are lying here. So I also prepared the gaskets. This is the air fitting, the jet, also for the decompression valve. This is how it is installed. And I also prepared the bolts, the head mounts, the cylinder block. So now I'm assembling the heads and installing them onto it. It was 150. Now I'm setting it to 200. We can do 190, 195 or 200.
We're tightening to 200.
The marks are crossed, and now turn it another 90 degrees and the mark should be lengthwise. So I've installed the heads and them, installed the push rods, installed the rocker arm, adjusted the valves, and next I'll be installing the injectors on the fuel pump. So the seating for the injectors here has been cleaned. I removed all the washers. Sometimes there are 2 washers, sometimes 3. Sometimes they're dirty or have carbon buildup and so on. So I removed all of that, cleaned everything, and installed 1 washer each. The thickness of the washer is 1.5 millimeters. So everything is ready on the engine block. I've prepared the injectors and the pump. We already had the injectors. During the repair, the nozzles were replaced, new nozzles were installed, and the stop line was also repaired. There was a replacement of the plunger pairs, I think, and the valves were replaced as well. I've also already installed new seals, a small one for the oil channel and the main one for the fuel pump. Well, we've also already set the mark. So if we look, here's a mark on the hub. Then here in this spot, there's another mark on the hub. There's also one more mark on the hub here. So this pump, the hub sits on the shaft without a key, which means it can be installed in any position. Therefore, when this nut is unscrewed, the hub is installed again and it ends up in a new position. And this mark is set on the test bench, meaning it's almost impossible to do without the test bench. The mark has to be set on the test bench. So check the tightening of these bolts. The injector nuts will be the old ones. Out of 11, I picked the ones that are in the best condition. Some of them had cracks and so on. And about the mark, now the fuel technician set this mark for me. You can see it here, marked with a marker. I marked it myself with my own mark, just in case it doesn't get erased. So now I'm installing it according to this mark. I've also already set the engine. My engine is set to 5 degrees before top dead center. Now we're installing the pump. So I've installed the fuel pump and I'm closing the cover right away. Everything here is cleaned and degreased. Check the threads. The cover is also washed and cleaned. I installed a new gasket, applied a thin layer of sealant here, and now I'm closing everything up. So I installed some pipes of camera, installed the coolant pipes, here to the compressor air pipes and so on. I installed the return line for the high pressure fuel pipe, the air manifolds, and now I'm going to paint them so that everything is the same color. I also installed the thermostat housing, I think I showed that. So next I'll be installing the clutch. This is new, it came with this engine. The pressure plate is old, it also came with this engine. I washed it, cleaned it and blew it out. There was a lot of rust, dust and dirt inside here. I used 2 cans of brake cleaner like this, so I washed everything out under pressure. I blew it out several times, cleaned it with a wire brush, so now the pressure plate is ready. Next I'm unboxing the turbocharger. The turbocharger has just been repaired. Here I also have manifold gaskets, a turbo repair kit, and somewhere around here I'll look for a stud that I'll be replacing, nuts and so on. So now I'll start painting the engine. I'll paint the manifold separately and the engine itself separately. We have a couple of days left and the engine will be ready. Готов. so the engine is painted. I've already removed all the tape and I've put the turbo on. I didn't film it because it's a pretty inconvenient process to do on camera. I've installed everything, put the turbo on, tightened this bolt and also tightened this third bolt. I installed it all as one assembly. This bracket, these pipes, the turbo and this pipe with the engine brake valve. Basically everything turned out pretty well. In a few words, I'll tell you what was done here. Well, obviously there are new gaskets everywhere. There's a new gasket here, there's a new oil gasket here, and new gaskets for the supply and for the drain. So we have new studs, new nuts. There are also new studs and new nuts here. So I also took apart the exhaust brake valve. It was stuck. Basically I worked on the shaft, got everything moving. So the bushings aren't worn out, the shaft isn't worn out. I put everything back together, checked it and everything works. So in this spot we have a spacer. I installed new rings. Now I just need to install the manifolds. All that's left is to install the viscous fan clutch and the fan. Well, that's basically it, and our engine will be ready. Alright, so I'm putting in the bolts with these big 10 mm washers because the manifold itself here is already corroded, and even though we replaced the original manifolds from this engine, they were in even worse condition. The customer purchased these manifolds and cylinder heads together. These ones are kind of better, but still these spots are corroded where this insert sits, and as a result the insert can go in crooked or drop in. That's why I put this kind of washer. Alright, that's it for this video. Thank you all for watching, good luck to everyone, and goodbye.